Good afternoon, everyone. Welcome to our session on embodied carbon and carbon accounting. On behalf of the Boston Society for Architecture, thank you for joining the 8th session of Embodied Carbon 101, the BSA's 12-part program series taking place this summer. The series will bring you embodied carbon programming throughout the summer, providing foundational knowledge in different impact areas and giving you tools and takeaways that you can apply to your everyday work. So I'm Lori Ferriss, the Director of Sustainability and Climate Action at Goody Clancy, a Boston-based architecture planning and preservation firm. And I'm thrilled to be joined by my speakers today, Jacob Racusin, co-founder and managing director of New Frameworks Natural Design Builds, a worker-owned cooperative championing ecologically minded building practices and full-service systems design in Vermont, and Maggie Wildnauer, consulting team lead for the Americas at Sphera, a provider of integrated risk management software, data, and consulting services. I'd like to take a minute to thank all of our sponsors for the series: Arc Woods and Services, Goody Clancy, Huber Engineered Woods, Kingspan, Nordic Structures, Select Building Products, and Thought Forms. We are so grateful for your support. And thanks also to our partners, Built Environment Plus, the International Living Future Institute, and the Structural Engineering Institute. And I'd also like to recognize that this program series is supported by the Carbon Leadership Forum and its local knowledge community, the CLF Boston, which we invite you to join if you are interested. So before we get into it, a couple of notes about the program. One learning unit is available for those who are eligible. We will share a link to a Google form in the chat box. So if you'd like a continuing education credit, please add your name, email address, and AIA number there. And if you're not an AIA member but want a certificate, please enter your name and email address. We are recording the session and it will be posted to the BSA website, architects.org, later this week for you to access. And throughout the entire session, we ask that you share any questions using the Q&A function. We may not be able to address them all today, but we will have plenty of time for Q&A at the end, and we will use them to address future programming as well. So with that, let's begin. So up to this point in the session, we've heard a lot about embodied carbon, what it is, why we should care about it, and how we emit carbon as part of the design and construction industry. But today what we're going to talk about is how do you actually account for that carbon? How do you quantify and calculate it and understand where it's coming from? And we've seen this chart before, but we understand that carbon emissions from the building sector come from both operating buildings and from the materials that go into buildings and from construction activities. And I think the industry in general is fairly familiar with the process of energy modeling, which quantifies the emissions from building operations, the operational carbon. But what we're talking about here is how do we quantify that other 11+% associated with materials and construction, and that is through life cycle assessment. And I just want to reiterate that you can't manage what you can't measure. And I think we've heard this need to quantify throughout the series. And previously, when we're only talking about energy modeling and quantifying operational emissions, we're just focused on this one little narrow piece of a building's life cycle. But it's really important that as we work towards these carbon mitigation goals throughout the world, we're looking at the whole picture. We need to understand where carbon emissions are coming from throughout a building's entire life cycle and when those emissions are occurring. But luckily, it's a fairly simple equation when you really get to the basics of life cycle assessment. You really just have to know how much of a material you have, and then you multiply that quantity times an impact multiplier, which the data is something we'll talk about, and then you get an environmental impact. And there are a number of tools and data sources available to the field now to help us do this. This is a snapshot of some software tools and data sources. This list is growing and expanding constantly, which is really good news. And both Maggie and Jacob will get into this and show their own versions of these graphics. But I also want to reiterate that it's important to understand what questions you're asking when you're looking at life cycle assessment and carbon accounting, because the answers you get out are really only good as the questions you ask at the beginning. And we're going to talk about these throughout the session. These are just a sample of a few questions that you might ask when you're thinking about performing an LCA. What product should I specify? Where are my opportunities for greatest carbon reduction in the design process? What's the carbon ROI or the carbon payback of a specific design decision? When will the emissions occur over the building? Is it before the year 2030 or the year 2050 when we really care? And can my building store carbon? These are just a sampling of questions that I came up with. There are obviously many more, which Maggie and Jacob will get into. So with that, I will turn it over to Maggie.
Great, thank you. Let me share my screen. Oh boy, here we go. Okay, can you guys see that? Good, yep. Great. Okay, great, thank you. So to introduce myself, I'm Maggie Wildnauer. I am Consulting Director for Sustainability Consulting at Sphera in the US. We used to be known as ThinkStep. We were purchased by Sphera last fall. So you may have heard of ThinkStep. Sphera is now the name you have to remember, and hopefully this is the last name change for a while. And we specialize in lifecycle assessment. We also are the creators of the Gabi software as well and LCA databases, as well as providing the background data for the Tally tool. So my goal today is to give you a little bit of an introduction to what is LCA in a larger context. I know we're focused on embodied carbon here, but I do want to make sure we all have the same grounding information about how these carbon footprints are being calculated. So what is lifecycle assessment? Lifecycle assessment is a way of looking at a product from raw material extraction all the way through disposal. So instead of just focusing on the impacts associated with producing a product, you take into account that it has impacts throughout its life cycle and potential benefits as well. So the goal is to look at everything from raw material extraction through intermediate intermediate material processing, as well as final product processing, transportation to the client, use, disposal, as well as any recycling. And then we account for all the natural resources extracted from the earth, as well as all emissions released to land, air, and water. This is all standardized by the ISO standard 14040 and 14044. And it's used, LCA can be used for any number of things. Some of the things are environmental management for a company, supply chain management, so understanding a little bit more about the impacts associated with your suppliers, design for environment, so using LCA as a tool as you're designing a material composition to choose materials that have lower impacts. Product labeling, which is where environmental product declarations fall into, as well as policy making. We're seeing things like California AB 262 come out with limits for global warming potential for products, and that is directly informed by LCAs. So the ISO standard has 4 parts within the framework of conducting an LCA. The important thing in this image is the double-ended arrows. So it's an iterative process. You may discover things as you're doing an LCA that require you to refine your goal and scope, to look for data elsewhere. You may want to include or exclude something later on, depending on the uncertainty associated with it. So there's always the opportunity to go back and refine. So the first step in doing any LCA is to define the goal. Why are you conducting the LCA? What do you hope to get out of it? That'll inform how you set your system boundaries. Then you determine the scope, so what is included, what isn't included, details like the functional unit, the where you're going to get data from, what impact assessment categories you're going to look at, etc. Once you define that, then you're going to do the data collection, and this is looking at just the primary data. So if you're an insulation manufacturer, you're going to look at all the inputs and outputs associated with your facility. Then the modeling process combines that with background data, and that is life cycle inventory data, existing EPDs, etc., that you combine to create a complete inventory for your product. That inventory gets looked at through the lens of impact assessment. So I'll talk about this a little bit more, but inventory is the amount of carbon dioxide, the amount of methane, and impact is global warming potential. So those each have their own contribution to overall global warming potential. And then you have to interpret it. You have to understand, where did you make assumptions along the way? Are your results sensitive to those assumptions? Do you need to consider the uncertainty around your results, because the amount of electricity used during the use phase of the product could be plus or minus 30%. So you need to consider how that affects the overall results. So when we talk about system boundaries, you've probably heard the term cradle to grave, cradle to gate. This is what we're talking about. So you start with raw materials. That's anything coming from the ground. That's crude oil, wood, water, etc. There's a materials manufacturing. So that's you've extracted ore from the ground that gets processed to zinc. And then you use that in your product manufacture. So that's creating the final product before it goes to the consumer. That's what we call cradle to gate. That is the system boundary that's really in the control of the manufacturer. They can kind of choose roughly what materials they use and where those come from, as well as everything that's going on at the actual facility. Once you add in after the facility, so transportation and distribution, which you could argue is somewhat under the control of the manufacturer, but depends on who's purchasing the product. The use phase, recycling, so does any of the product get recovered and then could somehow offset any of the inputs to materials manufacturing? And then final disposal, so landfilling or incineration. Once you add all these categories in, we've got cradle to grave. Another way to think about it is the modules that you'll see in environmental product declarations. So pretty commonly you'll hear the term A1 to A3, which is the production stage. That's basically cradle to gate. That's the bare minimum required in any EPD. Construction stage is A4 and A5, so that includes transport to the manufacturer, or sorry, transport to the installation site, and then any burden associated with installation. Use stage is the B modules, end of life stage is the C modules, and module D is any recovery outside the system boundaries. So you don't necessarily know that in 60 years the steel in your building will be recycled. It probably will, but we want to account for that. Once you add in all the modules, then you've got a cradle to grave system boundary. So I've said life cycle inventory a couple times. There's also, and I realize maybe I haven't defined that. So there's two terms, life cycle inventory and life cycle impact assessment. So life cycle inventory refers to kind of two areas. It's the amount of materials or energy required to make your product. So in this case, the amount of electricity, fuel oil, the emissions associated with it. So this is like upstream materials production. There's also that same information available for your manufacturing and the amount of fuel to distribute the product. So this is your life cycle inventory process. You might also hear of it as like a unit process. So it's all the inputs and outputs associated with making a kilogram of a product. When you combine that with background data, so existing life cycle inventory data, so the amount of emissions or resources required to produce a kilowatt hour of electricity, that is when you get the full life cycle inventory, which is the list of resources. So like I said, crude oil, hard coal, groundwater coming out of the ground before man has touched it in any way, or woman, and emissions to the environment, so air, water, land, etc. So after humanity has released it back into the environment or the watershed or what have you. So you end up with this long list of emissions that I don't know if a kilogram of CO2 compared to a kilogram of NOx is good, bad, medium, can they even be compared? So what we do is we translate to a life cycle impact assessment. So different emissions to excuse me, air or water or land have different abilities to affect the environment in some way. So methane and carbon dioxide have the ability to increase radiative forcing associated with greenhouse gas effect. We then assign equivalencies, so the kilograms of CO2 equivalent, to basically be able to talk about methane and carbon dioxide in the same units. And this is also done for acidification potential. So NOx and SOx have ability to form H+ ions, making the air more acidic and therefore rain more acidic. And then NOx and VOCs have the ability to form tropospheric ozone, which is summer smog potential. So these are your life cycle inventory here on the left, and on the right you have your life cycle impact assessments, and that is done so that we can come up with common metrics to discuss environmental impacts. So just another example, and we have the inventory value, so the amount of methane, the amount of carbon dioxide, and then we have the characterization factor. And Lori talked about this in her slides at the very beginning. So methane clearly has a lot higher impact on the environment. So in this case, even though we have way more CO2, the impact of the methane is actually higher on the global warming potential. So this is how we calculate the life cycle impacts. There's a number of life cycle impacts. Like, I know we're talking about carbon here, but it's important to remember that for every decrease in carbon or increase in carbon, there's trade-offs in other environmental indicators. Obviously, you can't expect everybody to be able to weigh all these different impact categories themselves without a lot of experience. So I think it's great that we're starting with carbon, but it is important to remember there's other things besides carbon. Examples include acid rain, smog, ozone depletion, particulate formation, etc. So you can go into this on your own. I'm not going to get into too much detail. The other tricky part about LCA is interpretations. Like, how do you use the results? What do they mean? What we have here is a basic contribution analysis. So you'll notice we're not focusing on the number, we're focusing on what is driving it, what is bigger, how do we get that lower, where are opportunities as a manufacturer to reduce my impacts. So we see here, and I apologize, the colors aren't great, but about 20, a quarter of it is from manufacturing, 2/3 of it is from use, and then maybe disposal and transport aren't the biggest things. And then we have a tree map over here which kind of really jumps out at you that active use of the product is what's driving it. So this is one way that LCA is so great, because it's really used for optimization. It tells me where's the low-hanging fruit, where do I focus on in reducing my impacts. Alternatively, I may have no control over the active use, so while I acknowledge it has a big contribution, I can't change that, so let me focus in on manufacturing. I do want to do a couple disclaimers. One thing with LCA is its potential environmental impacts. We always say global warming potential, acidification potential. We have no ability to predict absolutely that a kilogram of CO2 released now is going to actually have this global warming effect. Also, there's inherent uncertainty in LCA. You're combining data, so your manufacturer, you're trying to represent production for 2020. You're creating an LCA with background data that's actually from probably 2015 through 2018. And then you're going to use that in your EPD, which is valid for the next 5 years. So if you think about that, there's a huge temporal uncertainty associated with it. It's probably not going to change dramatically, but it's important to note that there is that difference. You're also using average geographical data. So I have an average data set for electricity produced in the US, or maybe that's not a great example, average, mining of some metal, but you're getting it from this specific location. And in fact, it's not going to give you the precise results, but it'll give you accurate results. So I just wanted to put that disclaimer. It's not that you shouldn't use LCA. The results are still valuable, but to 3 significant digits, it's maybe not that helpful, but order of magnitude is really where you should focus. We love using this picture. It's never going to be perfect. We know that, but it's going to get you somewhere, and it's going to get you to understanding if something is roughly better, roughly worse, roughly the same, also where you can improve. I also wanted to touch briefly on biogenic carbon in LCA. Carbon Leadership Forum did a great large session on just carbon and wood. And so you could spend weeks talking about this. So I don't want to get into too much detail, but basically, you know, people have this initial thought, okay, it's renewable, it's wood, it's absorbing carbon, therefore it's carbon neutral or carbon negative. But in fact, during processing, manufacturing, maybe even use and disposal, that CO2 may be re-released. So we have CO2 when the product is growing, but then you could burn it, you know, burn wood for fuel in processing, and then you release carbon dioxide. You may also incinerate it at end of life, and then you release that carbon. So it's not necessarily neutral or negative. It just depends on what happens over the life cycle. So it's really important to account for that when you're modeling. And the other thing to note is that if you have any of the CO2 or any of the carbon converted to methane, then that's actually going to have a higher impact than what it was withdrawn from the atmosphere when it was growing. So it could actually be it could not end up being carbon negative or carbon neutral. If you really want to dig into this, I put the link for the Carbon Leadership Forum's Wood Carbon seminars. You can get into a lot of detail, but I just wanted to touch on that briefly. Another thing to note is that obviously your EPD, your LCA data, it's only going to be as good as the data that's underlying it. So we have two areas of data, primary data and secondary data. Primary data is your bills of materials, details on, you know, technology, recycled content, etc., where it's coming from. That's coming from the manufacturer, and so they need to provide complete data. And part of that is on LCA practitioners like us at Sphera, who have to make sure that they have provided complete data. The secondary data is background data, the energy, the impacts associated with producing a kilowatt hour of electricity, environmental product declarations, literature. These are the sources of data that goes into another LCA. And so the goal is to have those come from reputable sources. You know, anybody could publish an LCA on their website, and it may not be complete or of high quality. ISO specifies details on data quality, and you need to discuss those in your report. A few things to note, or the couple things that I really want to dig into are completeness and representativeness. So when you're considering representativeness, you're modeling, like I said, you're modeling for a specific location, a specific technology at a specific time. So you want to get as close as possible to that, but you're never going to hit it right on. So it's important to be kind of as representative as possible, but know that you're never going to be precise. And then completeness, you want to make sure you're using a reputable source for your background data, as well as for conducting the LCA, because a lot of the completeness comes from just experience doing LCAs. And you may also want to dig into the available documentation. What are the assumptions behind the LCA? What year is the data from? Did they exclude anything that might actually be important? Stuff like that. When you're talking about data quality, especially when you're trying to choose an appropriate data set. So for anybody who's using Tally, you've got an average data set and you have a company-specific data set or EPD. How do you choose? And I just want to emphasize that in LCA in general, we're really looking for high accuracy but low precision. We understand that you're never going to be precise for the reasons I've already mentioned. So trying to get order of magnitude is the real goal. So you may be fine just choosing an industry average data set because it's going to help you make that initial decision. Do I use material A or material B? As you improve the selection of materials and you know what company you're getting it from, then you can increase your precision. So for example, I just pulled these from the internet and publicly available EPDs, but if you were making a decision between mineral wool and fiberglass, it doesn't really matter which one you choose between like industry average, which is the NAIMA, and the company specific, which is Owens Corning or Certainteed. You're still going to get a pretty clear answer which one is better for your project. And LCA and carbon footprint are only one of many metrics you would use to make a decision between these materials. So it's not necessarily that this is the only one, but if you have decided that as a specifier designer, the most important factor is the global warming potential, then you might look at this and say, well, we want to go with fiberglass. And I know that there's a lot of caution against comparing LCA results and EPDs, but ultimately that's what the EPDs are created for, is to give consumers an idea of the environmental impacts and how you make a decision between product A and product B. So while I do advise caution whenever comparing results, if you are, please make sure that, if it's an EPD, the product category rules are the same. That makes sure that any underlying methodological decisions probably will align. Certainly need to make sure that the functional unit is the same. Is it 1 meter squared a product at an R value of 1, or is it 1 meter squared at an R value of 10 or something? That's obviously going to be a difference. System boundary, have they included or excluded the same things? And in those things that are included or excluded, could that actually have a big impact? Reference service life, are the products actually equivalent? Are they functionally equivalent? Can you use them for the same amount of time in a building? If not, if you have to replace one product twice, you should take that into account. Reference year of the primary data. So ideally they would have the same reference year or as close to it as possible. Background data ideally would be the same, and the reference years would be pretty close. So they're, on the next slide, I'm going to get a little bit into what different background data sources are, but it's important to make sure that your background data is the same. If there's any assumptions made, and then if there's any methodological decisions. So those things could all affect the ability to fairly compare. And then last slide, just a few examples of data sources, focusing really on life cycle assessment. So not just carbon, some of them are, but a lot of these, like the databases themselves, all give you life cycle inventory data. I know Athena gives you life cycle inventory data, and then industries also publish their own data, which is available usually in other LCA software. And I think I maybe went over on time, so that is my last slide, and I'll pass it off to Jacob.
Can you all see my screen?
Yep.
Great. All right. Well, brief introduction. I'm Jacob Deva Racusin. I am the Director of Building Science and Sustainability with New Frameworks. We are a worker-owned cooperative design build firm up here in Vermont, focusing on the integration of low-impact materials and high-performance designs. So that was fabulous and is a great kind of baseline for the sort of practical application and sort of mechanics of accounting that I'm going to go through. I'm going to keep it pretty high level. There's a ton of really good information out there for each one of the different tools and sort of specific kind of cases that we'll be looking at. I'm going to start. I want to start kind of from the biggest view. The actual mechanics of accounting and the use of tools is the place that a lot of people start thinking about, and sort of the most like direct kind of point of entry. But there are a lot of other pieces that need to be in place before you start, sign up for that free subscription to that LCA tool and digging into it. And really want to make sure that we took a minute just to look at those pieces as well, because the technology is one piece, but the ability to integrate that into your practice and have information that is actionable and useful is an important part of this. And so trying to put the actual accounting process into the bigger picture is pretty relevant. And Maggie hit on a bunch of those. Lori did a great job in asking a bunch of those questions right at the head. Got a few other ones here. We won't get super deep into these just in the interest of time, but just to kind of frame the extent that we're looking at beyond just the actual mechanisms of counting. So maybe one of the biggest ones is just acknowledging that it can be pretty difficult, depending on the culture of your firm or your practice, to start doing something new and to bring in a new point of analysis and to even bring in a new technology. And some of that is really the actual, facility of working with a new tool. And some of that is the difficulty of embracing change in the sort of assessment of your practice, and particularly recognizing that LCA and carbon accounting is relatively new as a field, certainly to the extent across the AEC industry that we're that it's starting to become introduced. So it's not like this has been done as an industry-wide practice for a generation, and we have a host of different best practices established for all sorts of different firms at different scales. There is a whole, we're very much developing those in real time collectively. And I've been talking with a few folks of recent about, starting to bring carbon accounting to the practices. And, we come from a culture, particularly in the world of architecture, that tends to be pretty competitive and tends to see failure not as a stepping stone towards success, but as something to avoid. And I've heard multiple times, like, I tried that and it didn't work, and so I didn't try it again. As well as, I tried that, but I didn't really want to tell anyone, or I felt a little embarrassed, or I didn't want to show a weakness around the fact that that analysis didn't make sense. So yeah, it just didn't really work for us. And so just recognizing that as a potentially significant barrier to being able to bring carbon accounting into your practice, not just trying the tool once or twice or thinking about carbon in general, but really having an established protocol in your workflow that allows you to look at climate impact as a sort of basis of your decision making. In many cases, this may well be the case. And so depending on who you're working with and your own relationship to this concept of failure or trying something new, just know that that may be a piece of this whole puzzle that needs to get attended to. So just to look at a couple of these different questions and sort of frame out as we get into tools, which tool might be better used for what. One common question is, which is better, this option or that option? And so one way you might see that is looking at early in schematics, looking at some different massing models or some different schemes on your building approach. And you want to get a sense of, which one of these A, B, or C is going to have a higher impact in carbon. That might be one question you're looking to answer. That same question of this versus that may show up on a very detailed material basis. That's where, is this wood fiber board or this mineral board going to be better from a carbon standpoint, or by what magnitude? And so that sort of direct comparison, whether it's big picture or micro, it's kind of one batch of questions you might be asking. Another would be, how much better is this, and then compared to what? And that introduces a concept of baselining and having, if your goal is to improve your design, again, compared to what is that baseline? So that could be, my massing scheme, compared to a baseline of your generic clip art building, or my, sexy new carbon storing building insulation product compared to the average practice of, say, a foam board product. So how you establish that baseline, what that baseline is, and how you define what improvement is relative to that baseline, all become additional, points of relevance in the analysis. And you can have some really poor analysis and come to some poor conclusions if that baseline has not really been clearly and well established, and it isn't transparent to understand what that's comparing to. And there's, you can kind of game that system and come up with some misleading conclusions if that's not attended to. So that's just another batch of questions and series of variables to consider. If you're looking more of a quantified approach, like how much carbon is this product emitting, or even more complicated, is this building emitting? That quantification has, again, some more variables that need to be brought into the equation. Maggie did a great job of really exposing a lot of these variables from the LCA process, but it's around, the sort of yellow questions would be, what are we including in the scope? Are we counting all the interiors? Are we counting sort of changes over time within the normal expected lifespan of this type of building? MEP, mechanicals, electrical, and plumbing, huge levels of impact that are frequently not included in a lot of assessments, especially if they're just looking at building shell or structure. That can be a pretty significant number. And then how micro are you getting? You're looking at all the fasteners and adhesives and the membranes. So that's more like how much you're counting within the building. And then there's that scope of, beyond the building itself, what might be considered. And, again, looking at that LCA structure, there's different modules. Will show you where within the lifespan of the product, but also within the building, emissions are occurring. I'm using the word material carbon storage here with acknowledgement, as Maggie was discussing, that at the end of life of a bio-based material, that carbon is not expected to be permanently bound in that building because our buildings aren't permanent. So whereas sequestration, in my understanding, is more of a longer term binding of that carbon, I tend to use the word storage when I'm looking at it in a building context, so the acknowledgement that that could be reversible and it could be re-aerosolized, or that carbon could be combined with hydrogens to create methane or what have you. But there's also impacts in land use and soil emissions, and whether or not you're counting some of that transportation and the accuracy of that, et cetera, is another batch of questions that'll be just important to acknowledge those variabilities and understand if you're comparing across different buildings or different choices will affect the true quantification of that accounting. And then again, when we're getting into the quality of that data, whether it is more industry average or product specific, even sort of just in time or custom batch specific, that depending on what level of information you need and what questions you're trying to answer, you will use different tools at different parts of the process with different levels of granularity around that specificity. And we'll go through that with comparing and contrasting some of the different tools. So as we get towards quantification as the goal, then that becomes relevant, as opposed to just accepting some of these as a common baseline condition across the different sort of comparative buildings or choices you might make. And then if you're going for a program certification, and part of your goal of accounting for carbon is to comply with the program or to get a certification, obviously you're going to need to check those program requirements. So, a couple examples: the ILFI zero carbon certification has its own prescribed tools that it accepts and its own process around counting embodied carbon. Dummer is a township in Ontario that now requires a declaration of the embodied carbon for residential new construction, and it needs to be below a set limit, which is pretty impressive. They couple that with a carrot of an incentive for builders that meet that limit. And they require use of a tool that Builders for Climate Action has developed specifically for that compliance. So we'll take a peek under the hood of that tool in a little bit. Just a little plug for Mass CEC, since this is kind of a hometown crowd here. They are just announced a triple-decker retrofit competition, design competition. So retrofitting for 3-story multi-unit buildings. And one of their criteria for that competition is the embodied carbon. And so a modified version of that BCA carbon accounting tool is what's being used for compliance there. So if that's your goal, you'll want to know what the rules are and use those tools accordingly. Another really big question here is who's the audience? So the analysis, oh, lost my mic. Pardon me. So the analysis is only as useful as it is actionable. And so it's one thing to get really good data. It's another thing to have that data be useful in creating change within the practice or shaping the direction of the design. And so it should be abundantly clear at this point, there is a lot of different information that can be combined and packaged and referenced in a bunch of different ways. Some of that is tabular, and for those of us that are used to looking at spreadsheets, that's a really good, specific, quantized way of being able to look at data, but it's pretty hard to interpret, and it's hard to look at patterns quickly. On the right there, all the way to the right, is an output from one of the programs, Tally, that can clearly tell is coming from an architectural background in its development. There's a lot of really pretty visualizations. There's a number of them, and the data is combined in a bunch of different ways to make for more familiar bar graph and stack bar graph approaches, which is pretty familiar to a lot of us, and that might communicate a little more clearly and cleanly to non-technical audiences. EC3, we'll look at this in a minute, has a Sandpit diagram, which always takes me like a few beats to really understand what's going on there, but is like super data rich within a really compact visual. So suffice to say, understanding whether this is just for your own benefit, whether you need to share this internally within your firm or within the other design team partners, or externally to clients or stakeholders, understanding how to communicate all this really good carbon accounting work you've done is a really key part of the process and may inform which tool is most appropriate for your uses. So seeing again here a host of different tool solutions. Just gonna we'll go through a few of these. We're really not gonna spend too much time getting deep into any of them, enough just to kind of paint a palette of what's out there and the different types of tools. So at this point, it should be clear these LCA tools, Maggie kind of got into some pretty good depth around what LCA means and what's included in there. Tally's the one our company uses. That's why I keep referencing their graphics, because that's the tool we happen to use in-house. It works off of the Revit platform. So if you use Revit for design, Tally's a great option. One-click LCA is a close competitor, has a lot of very similar features, but is not coupled to a specific design program. And Athena Impact Estimator is a free program that, again, you sort of do your data inputs differently than you would if it's synced right into your design software. So those are all LCA tools. There are also some specific carbon accounting tools. Again, like Maggie was saying, carbon is not the only thing that is being assessed through the LCA process. If you really are looking specifically in embodied carbon, there are a handful of tools that are dedicated directly to that. We'll look at EC3 and the Builders Climate Action tool I mentioned. There are also fuel specialty tools that we'll look at that are designed for very particular points of reference. And then those tools are not to be confused with the data sources and the databases. So EPDs are one great source of data. We're not going to talk a lot about using the raw data or going to EPDs or going into databases like Circular Ecology's Inventory of Carbon and Energy database, which have been developed for folks to be able to reference and use and do some of their own kind of custom calculations. There is a whole process there. Maggie really referenced a bunch of the different caveats and points of consideration for making that data comparable. Obviously, there's a whole thing there. We're not going to get into those details, but that would be, this is a EC 101 level. That would be more like EC 201 or further level, because you just have to take a little more responsibility of interpreting some of that data as opposed to having the tool assist you with that. And then there's the LCI databases, which it's very unlikely that especially anyone sort of just getting into this process is going to go straight to those. But that is going to be the back-end data sourcing for a lot of these tools that we're looking at. I know that the EC3 and the Builders for Climate Action tools refer back to EPDs as their source data, whereas a bunch of these LCA tools are using these LCI databases as their data sourcing. So that just paints a little bit of kind of all the tools versus the databases, what's out there, what they might be looking at. And let's just take a little bit of a look at workflow and sort of the outputs of those tools. So again, like when we're talking at the beginning of asking different questions, you're going to have very likely going to be having different questions coming up at different phases throughout the design process. If you're a designer or an architect and you're kind of getting right in on the ground floor, again, those early questions around massing and impact would lend you to be doing some early LCA modeling kind of on that high level. The design hasn't matured to too much specificity, but you may have a fair amount. And then certainly there's going to be big questions around how many stories and how many corners to the building and whatnot. And for me, this is very analogous from anyone that comes from a background. I come from a background in energy modeling, and anyone that has done a fair amount of energy modeling, it's very similar. The earlier you do that in the process, the cheaper and easier and more facile it is to make changes in the design before it's too far down the tracks based on some of that early feedback and information. But that will very unlikely be the only time you're looking at that information. You're doing a high-level pass at an early phase of design to help steer the design towards your expressed goals, in this case around reducing your climate impact and carbon emissions. Once you get into design development and you've got a whole lot more definition around the materials in that assembly, or comparing different assembly types or different finishing materials, or what your interiors palette might look like, at that point, your analysis and your tool usage will be a little bit heavier. You've got more to look at. There's more bits and pieces. You can see just by the bar graphs here, there's a lot more little pieces in there, and that's where maybe a bit of a heavier lift and a little more roll up the sleeves work in that analysis, as you've got more detail to inform those decisions. And then it'll take you on to construction documents. I'm taking these graphics just to give credit from Tally, because it does a great job of talking about this workflow here. By no means endorsing them specifically, just for full transparency. But that's a really cool thing about the advent of EC3, which is a relatively new tool to our industry, which is really designed to kind of pick up levels of detail and analysis where sort of industry-wide LCA that isn't product-specific kind of leaves off. And so if your questions are this product or that product, or when you're really more on the construction side of things, now moving in towards procurement, and really trying to understand, is there a better sheetrock to use, or really trying to drill down to those levels of granularity in your decision making, that's where a tool like EC3 that's looking at EPDs, particularly EPDs that are released by manufacturers for a specific product, that has data that traces it back to a particular plant. They may show variations between different plants. If you're really trying to bring that level of rigor and really get, or have more thorough quantification of the carbon impact, not just like generally as an industry-wide material, but for this building, this is what the impact was. That's where you may switch tools, and it'll be a different set of data, answering some different questions at a different part in the process for a different sort of scope of analysis. So that just kind of gives a good sense of, in our practice, we've been using both of these tools in this fashion to really be able to understand the climate impact that our design has, not just moving through the design process, but as we really get into construction, as the design build firm, we've been able to really start to use that a bit to get a better understanding of that impact all the way through. So just to look a little more closely at what we see when we get this information back, this is one of a series of different visualizations that come out of an LCA report. Again, in this case, because I'm using Tally, I was able to grab some documentation there. And they're breaking it up. You can see the legend on the right here, those different modules that Maggie's referring to, the different points in the time frame of that material life cycle. We're looking, the red series is that cradle to gate process. Transportation is getting it to the site. Maintenance and replacement, kind of that use phase, and then the end of life. And so within those color-coded categories, we're breaking this out by division of material across the building. So this is a great way just to do some really quick impact, sort of hotspot analysis of like, hey, what are the big colors and where are they, in the building, what divisions? They'll give you a really, pretty quick visualization of if you are wanting to dial down the impact of your building, you can get a pretty quick look. And this is one of, I don't know, maybe a half dozen or more different ways of sort of packaging up and comparing this information. Again, looking at a different source of data and a different stage of the design or construction process and a different visualization. Now we're using a Sandpit diagram, and we've got all the different sort of raw materials, not raw materials, but the different sort of material sources: steel, ready mix of a couple of different flavors, some rebar. Shows how those different materials flow into the different parts, or the different divisions of your materials list, into which different components of the building. And it's just another way of kind of analyzing and looking at how all that sort of flows through your project. The detail that goes into that pretty picture is also another really great thing about EC3, and it looks at that EPD level information, because it's comparing a whole bunch of these different product declarations from a whole whack of different products and different divisions. You get some pretty direct immediate product comparisons. And so within that, the tool is able to establish a baseline. So again, if you're doing baseline analysis and your targets are around a reduction from baseline, this is a tool that gives you that pretty visually and pretty quickly. Of all the EPDs for that material in the tool, it tells you what that baseline is and what a reasonable target is that you should be able to achieve based on your procurement specifications. So that can be handy that way. And then of course, the transparency of that data is a huge part of it. And you can look up the individual EPDs for those products. You can get a sense that you can filter it by your location to dial in the accuracy there, and your what plants you may be sourcing your material from, et cetera, et cetera. So different information, different level of granularity for answering different questions at a different part in the process, just to give some contrast there. And those two tools have been sort of designed to be used together to bring you all the way through the process. Again, those are not by no means the only two tools. That's just one kind of example of how you can use a couple of tools together to complete that workflow. Another way of looking at EPD level analysis specifically for embodied carbon is this tool that Builders for Climate Action has developed. So Chris Magwood, who is director of the Endeavor Center, has put a tremendous amount of work into creating this tool. And then we've been working together to bring it to a couple of different applications. And the idea was to make it a much easier point of entry for those that are not in an architectural practice, but are involved in design decisions, or for builders that are not really heavily involved in the design process, but want to understand the impact of their decisions. For folks that aren't working on a BIM design platform, and just want an easier way of being able to plug in a bunch of information and get a whole bunch of data back. This is a simple sort of spreadsheet-based tool that will have a web version where the inputs is very similar to a UA calculation. If you've done basic energy modeling, basic building dimensions get plugged in. We'll take a look at the different levels of output, but plugging in for your different types of the assembly, your interior walls, exterior walls, floors, ceilings, etc. And then you get a total carbon output, and this is embodied carbon dioxide equivalent output, as well as carbon intensivity, so kilograms of CO2e per foot squared. And this is just looking at A1 to A3, so cradle to gate with a few items that are in A5 when the materials are being installed. So once you get into the tool, all these quantities you've already filled out, and then you can just check and select which parts of the assembly you want to choose for consideration. But what's great is you can see revealed for all the different pre-populated framing types, installation types, et cetera, you can see what the values are for that given quantity of material and for the R value specified if it's an insulation material, and then be able to choose accordingly. There's also a percentage factor there. So if you're using a combination of two different installations to get your total R value, you would just check multiple boxes and enter your percentages accordingly. So this is more of a quick flyweight way of getting both comparative analysis across these different materials, but also a quantified analysis within the scope boundaries of cradle to gate embodied carbon sourced from EPDs. And then again, there's a few of these to kind of wrap up here. There's a couple of these specialty calculators that are out there. This is just a very, very small selection of a host of tools that are out there in the world, and more coming online every day. But just to give a sense of the diversity of tools that are out there, Thornton Tomasetti has recently released Beacon, which is an embodied carbon tool specifically for structural engineering. So that's designed for PEs to be able to get the feedback specific to the scopes of the building and the processes in which they work. There's a bunch of different tools out there specifically looking at concrete. So Circular Ecology, the same folks that now host that inventory for carbon and energy, also have an embodied carbon model for concrete. Climate Earth is another great resource for carbon accounting in the concrete world, and they've got a bunch of free tools on their site as well, so you should also check them out. And then on the biogenic side, Again, that's a super slippery one, as Maggie referenced, and I also would second, definitely go check out Carbon Leadership Forum's series on wood just to get a sense of the complexity of biogenic carbon. In our practice, we use a lot of straw and other agricultural residue materials that are a whole different series of variables than wood. So it's, you know, the world of biogenic carbon is actually quite complex and diverse and beyond just wood. So just looking at a couple of tools to assess that, WoodWorks, which is the Wood Products Council, has developed a tool that looks very specifically at the amount of carbon that is stored in the wood in the building, based on, again, your dimensions and your specified species and forest sources and you know, timber types, and translates that into what that equivalency is in greenhouse gas emissions. So that's just looking very specifically at that calculation. This Build Carbon Neutral tool is looking, it sort of gives a very sort of basic assessment of the impact of a building, but also broadens the scope greatly to look at change in land use, as well as soil carbon emission impacts. So that's another different sort of scope and set of data to be looking at. So, and again, a dozen other tools out there for different points of reference in your analysis, depending on the questions you're looking to answer. I will stop there and pass it back to Lori for questions.
Thank you. All right, thanks Maggie and Jacob, that was great. We've got a few questions live here. I think we have time for a question for Maggie. How are the geographic, temporal, and technological differences in LCIs accounted for in an industry-wide generic type 3 EPD?
So the goal with any industry average EPD is to be as representative as possible. So we try to get a good fraction of the production volume, and if we can't, if there's a lot of small manufacturers, we try to get a cross-section that represents the geographical representativeness. If there's multiple technologies, same thing, we want the right mix, but obviously if there's two different technologies associated with making that product, you're only going to end up choosing one for your when you get the company specific version. So there's maybe a little bit more uncertainty associated with it, but it should give you order of magnitude. And generally, if there's going to be dramatic differences in the technology types, we would probably suggest separating those results. So so the attempt is to be as representative as possible, but certainly there's more variation within an industry average than company specific.
All right, let's do one more. Can we recommend any embodied carbon databases for buildings? We've been referencing the databases by the Carbon Leadership Forum as well as RICS in the UK. Are there others that you're aware of?
For databases, the only one I'm aware of, specifically in a database form, is the inventory of carbon and energy from Circular Ecology. That was originally a project at the University of Bath in the UK, and Circular Ecology maintains that. So for building, for databases specifically, for buildings specifically, that's the only other one other than the RICS that I'm familiar with. Maggie, I'm not sure if you know of any.
Yeah, I mean, you could dig into the tools, certainly like Athena and Tally. There's ways, you know, you certainly would get the carbon footprint, but you would need to enter in some information before you just get it out. It just doesn't give you the impacts per kilogram or what have you. Beyond that, you know, certainly the EPD databases hosted by like UL and ASTM and NSF would have, and SCS would have some information available, but it's much more digging into it.
Yeah. And I think if the question was more about the building scale, about benchmarking data, I think that is also something that there aren't too many database or, you know, benchmarking studies done beyond what the Carbon Leadership Forum and RICS have done. And I think hopefully we'll start to see more of them once regulations requiring reporting of carbon footprint start to pick up a little bit. Let's see. All right, one more minute. So I think that's probably all we have time for Q&A. But there were some great questions, and I think a lot of good food for thought for future programming as we develop some 201 content, and great introduction to all these topics. So thanks again, Maggie and Jacob. That was fantastic. A really good introduction to life cycle assessment, the the concepts and principles behind it and the tools that are available, how we can bring them into our practice. Another thank you to our sponsors and to our partners. Once again, if you haven't already and you would like continuing education units, please enter your information into the Google spreadsheet that was pasted into the chat box. Look at that. And don't forget that next week we continue the series with a session on certifications and commitments. It's going to be a really good one about how to bring this into your practice and apply LCA concepts to some of what we're already doing with certifications. So be sure to tune in and look out for the recording of this session, which will be available shortly to you all via email. Thanks, everyone.
Thank you.
Thank you.